Hello and welcome to week 2 of distance learning. This is Mr. Prather with this week's math lesson. Last week we focused on volume and we found out that volume is the number of cubic units or cubes it takes to fill up a three-dimensional shape. And we also discussed that as we explore volume, we're going to be using a rectangular prism as our three-dimensional shape. A rectangular prism or box is three-dimensional because it has three dimensions. It has length, it has width, and it also has height. One strategy for determining the volume of a rectangular prism that we talked about last week was simply adding up all of the cubes that it takes to fill up a rectangular prism. We're going to take some time to review that strategy with the warm-up activity we're about to do. I need you all to take a look at this rectangular prism that I have drawn, and I want you to determine the volume of this rectangular prism by adding up the cubes. Now here's something you need to remember. When you are adding up the cubes, you need to also consider cubes that you cannot see. That was one of the things you had to do in the volume game that you played online last week. You had to add up cubes that you couldn't see. So keep that in mind as you're figuring this out. So you can pause the video and take as long as you need to figure out the volume of this rectangular prism. And then when you're done, continue the video and we will talk about how this problem was solved. Have fun. Welcome back. How did you do? Let's take some time to discuss how we can determine the volume of this rectangular prism by adding up the cubes. Well, when I look at this rectangular prism and I look at the front part, I can see that there are 9 cubes. But when I look along the side, I can also see that there is a back part that has the same number of cubes as the front because it's a rectangular prism, so they're going to be the same. So I can take the 9 cubes from the front part and add 9 cubes from the back. And as we discussed, there are many cubes in the back we can't even see, but we can conclude that they are there. And then we add 9 plus 9 and get 18. So all together, this rectangular prism is filled up with 18 cubes. Now, to be mathematically correct, we have to write the volume in a certain way. So I would write 18 cubic units for the volume. Or I could write it this way. I could write the number 18, write the word units, and put the exponent of 3 because we're dealing with 3 dimensions. We're dealing with length, width, and height. Now last week when we were reviewing finding the area of a rectangle, we discussed how area is always written in square units, which has an exponent of 2. Because when you're dealing with area, you're dealing with 2 dimensions, length and width. When we talk about volume, we're adding another dimension. So we end up with 3 dimensions, length, width, and height. So how did you do? How many of you were able to get 18 cubic units for the answer? Well, if you weren't able to get that, the most important thing is that you tried your best. Right now, I would like for us to take some time to discuss the objectives we'll be covering in today's lesson. The first objective is students will use multiplication to determine the volume of a rectangular prism. And the second objective is students will determine the volume of a rectangular prism by dividing it into layers. So we have a lot to cover today, so we're going to go ahead and dive into the very first objective. Well, in order to use multiplication to determine the volume of a rectangular prism, what I'm going to do first is I'm going to look at the 3 dimensions of this rectangular prism. So first I'm going to consider the length of this rectangular prism, and I see that it is actually 3 cubes. So I'll write that down. Next, I'm going to consider the width of this rectangular prism. And I notice that this rectangular prism has a width of 2 cubes. Finally, I'm going to consider the height, how tall this rectangular prism is, and I can see that it is 3 cubes tall. So the height is 3 cubes. Now we already have determined that the volume of this rectangular prism is 18 cubic units. So my question for you is, what can we do to these 3 numbers to end up with 18? What do you think we should do? Perhaps someone thinks we should add those numbers. Well, let's add them and see what result we get. Well, 3 plus 2 is 5. But plus 3 is only 8. So that means we're 10 shy of the 18 that we need to have. So addition is not the way to go. What else should we do? Multiply? Let's see what happens when we multiply. If I multiply 3 times 2, I get 6. And then if I take that 6 and then multiply it by 3, I get 18. Students, we have just unlocked the secret for how you can use multiplication to determine the volume of a rectangular prism. All you have to do is multiply the length times the width times the height. You multiply all 3 of those dimensions together and you will have the volume of the rectangular prism. And one thing to keep in mind is when you're multiplying the factors together, it doesn't matter what order you multiply them in. You will always get the same product. Now, when we multiply 3 times 2 first. Let's see what happens if we multiply the 2 3s first. 3 times 3 is 9. Look, times 2 is still 18. So keep that in mind when you're figuring out the volume of a rectangular prism when you're using the formula. Well, right now, I would like to give you an opportunity to practice using this formula. So I have a rectangular prism that I need to show you. And if you notice, this rectangular prism has a length of 6 feet, a width of 4 feet, and a height of 5 feet. So I want you to take some time to see if you can determine the volume of this rectangular prism. Again, just pause the video, take as long as you need, and then when you're done, turn the video back on, and we will continue. See you in a little bit. Have fun. Welcome back. So let's see how you did. Again, I wanted you to use the formula for finding the volume of a rectangular prism, multiplying the length times the width times the height. I wanted you to use that formula to determine the volume of this rectangular prism. So let's do that. Well, first of all, we see that the length is 6 feet. And we know that the width is 4 feet. And I'll put the unit of measure. And we know that the height is 5 feet. So I am going to plug our numbers in. So we have 6 times 4 times 5. And as we discussed earlier, it doesn't matter what order we multiply those factors in. I'm going to start with the 6 times 4. Well, if I multiply 6 times 4, I get 24. And I still need to multiply that by 5. So I'll do that over here to the side. I'm going to do 24 times 5. 5 times 4 is 20. Carry the 2. 5 times 2 is 10. Plus 2 more is 12. So I end up with 120 cubic feet. So I wrote the unit. We know the measurement of the cube. It's feet. So it's feet and it's a little 3 to show 3 dimensions cubic units. Now let's write those 3 factors again. And I'm going to put parentheses around the 2 factors I'm going to multiply first this time. This time I'm going to multiply the 4 and the 5 together first. Let's see what happens. 4 times 5 is 20. And then I have to multiply that 20 times 6 And I'll do that over here just to work it out. 6 times 0 is 0. 6 times 2 is 12. Oh, we still get 120. So it would still be 120 cubic feet. So that is how you use multiplication to determine the volume of a rectangular prism. Well, the next thing we need to do is we need to focus on the second objective, which is how you can determine the volume of a rectangular prism by breaking the rectangular prism down into layers. So let's see that. We're going to go back to the original rectangular prism we were working with today during our warm-up. And what we're going to do is we are going to look at the different layers. And when I think of layers, I think of like a layer cake, when you have one layer on top of another. And if you look at this rectangular prism, we do indeed have layers. We have a bottom layer, we have a middle layer, and we have a top layer. This top layer gives us a good view of the cubes that are involved. And if I look at the top layer, I can say that the top layer has two groups of three. We have two groups of 3 cubes. Two groups, that's one group of 3, and that's another group of 3 cubes. So that's one way we can express what the top layer is showing. And I have recorded that on this chart here. We have 3 layers, and we are observing what we notice about the top layer. It has 2 groups of 3 cubes. And we can take this information and put it into an equation. Here's the 3 that shows we have 3 layers all together. And in the parentheses, we have a description of what we see that the layer is made up of. It's made up of 2 groups of 3 cubes. And then we can work out that expression. We'll multiply what's in the parentheses first. We do 2 times 3 and get 6, and multiply 6 times 3 and get 18. So that is another way of determining the volume of that rectangular prism, by approaching it by looking at the layers. But guess what? Not only can we represent this top layer by saying it's 2 groups of 3, we can also say that it's 3 groups of 2, and we're still naming the same space. Doing this kind of reminds me of when we worked with arrays, when you learned about multiplication, and this is the exact same concept. So we could also view this as being 3 groups of 2. And we're still referring to the same layer, and I have that represented down here. Still the same 3 layers, but we're looking at the top layer differently. We're now looking at it as being 3 groups of 2 cubes. And then if we put that into an equation, we have the 3 layers out here with the multiplication sign, and in parentheses we describe what that layer is made up of. It's made up of 3 groups of 2 cubes, and then to figure out what that's equal to, we can multiply what's in the parentheses first. 3 times 2 is 6, times 3, we still get 18 cubic units. You are going to be working on an assignment today that will require you to focus on the layers of a rectangular prism. What you will be required to do